All right, welcome back. Today I'm gonna do a section from chapter 15 of chemistry talking about the ionization of water. And the ionization of water, basically, if you add water plus water, water has the ability to act as an acid or a base. And so some protons or H pluses will get donated from one water molecule to the other, forming hydronium ions as well as hydroxide ions, and vice versa. So this reaction is reversible. And it shows that these two ions share the same concentration. Your hydronium and your hydroxide ions are equal to each other to be neutral. In this case, 1 times 10 to the negative 7. Now, we haven't talked about the pH scale yet. That's kind of tomorrow's lesson. But the pH scale tells you how acidic or basic a substance is, and it's a scale of 1 to 14. And it's a scale of a power of 10, hence this times 10 to negative 7. So when you see times 10 to negative 7, assume pH 7, because it's power of the 10 to 7. And 7 on that scale is neutral, and anything below 7 is going to be acidic, and anything above 7 times 10 to the negative, whatever, like we'll say times 10 to negative 10, that would be considered basic. So we can set up an equation called the self-ionization constant of water, or K equilibrium, where H3O plus and hydroxide together have to equal the pH scale of 14. Okay, so this is stating that in any aqueous solution at 25 degrees Celsius, no matter what it contains, the product of H plus or H3O plus and hydroxide must always equal to the 14th. So if you add acid, you get an acidic solution. Your H plus or H3O plus is higher than your OH. If you add a base, you get a basic solution. Hydroxide's higher than your hydronium or H plus. If H plus or H3O plus equals hydroxide concentration, if the concentrations are equal, then you get a neutral. So today's equation is really, really simple. This is the one we're going to be dealing with. K equilibrium equals the concentration of your acid, H3O or H, times the concentration of your hydroxide, that's your base, has to equal 1 times 0 times 10 to the 14. So in your problems, you're either going to be given the acid or the base, and you just divide to figure out the concentration of the other. So let's take a look at sample problem here, 2 sample problems. All right, so I'm given the concentration of an OH. So I'm given this, and I need to figure out the concentration of my H plus. So my equation is K equilibrium equals this times, equals that. Okay. So I'm solving for H plus. This is my OH. And it equals this. So how do you get H plus by itself? Well, divide both sides by this. Oops. So you're going to need a calculator for today's lesson. So 1.0 times 10 to the negative 14 divided by 1.0 times 10 to the negative 5, you get, hold on, sorry, I typed it in wrong on my calculator. Divided by equals 1 times 10 to the negative 9. And if you look at this, if you were to add negative 9 plus negative 5, you get negative 14. So this works out. So that would be your answer. That's it. See, another sample problem. This time we're given this H3O. That's going to be my H, so we're going to be solving for OH. So how do you get OH negative by itself? Well, divide both sides by 1.0 times 10 to negative 2. All right, so the concentration of my OH and this makes sense because anything above 7 is basic, and we're looking at OH concentration. In this case, we have minus 12. If I look at my acid, that one, never mind, I'm just going to skip that. I solved for the wrong one. No, maybe not. Maybe this might have been supposed to be an H. This is supposed to be OH. My bad. Okay, so let's do one more sample problem, and then these 3 will be your assignment. And I'll actually give you the answers. You just have to show your work. So H3O plus equals 1.55 times 10 to negative 2. So solve this. You're going to take divided by this. So divided by 1.55 times 10 to the 2 negative, and I get and this, so because this is my H3O, this would be my OH. Okay. So I'm actually going to give you the answers here. So when you do the math, you should make sure you show your work. Otherwise, I'm not going to give you credit for it. So let me find my select. So the answer for number 2, you should get that, and for number 3, and for number 4. So make sure you show your work. Make sure you know how to type it in a calculator because you will see some of these on your test. All right, that does it for today. Tomorrow we'll talk about the pH scale in depth.